Hello, my name is Cody Spicer, and today I will be talking to you about a doorbell screening project that I worked on this semester. As you can see, I'm a graduate student here at Colorado State University. I'm in my second year of my graduate schooling, and I am pursuing a degree in electrical engineering. So today, I want to go over the purpose of the project I have worked on, the description of the project, so that way you guys can get a feel for what I was trying to accomplish here. The hardware behind it, the software behind the hardware as well, and then future improvements that we could do later on down the road to better improve the project. So the purpose of the doorbell screening project is to minimize the amount of interruptions you are having during the day. Let's say you're working on a project for work, or you're playing video games at home and you don't want to be distracted, but you hear the doorbell ring. A lot of times people feel obligated to go answer the doorbell, and then a lot of times it's just nuances that they don't really have to deal with, such as solicitors or political party discussions, especially now this time of year. Also, annoying neighbors can be coming over to complain about something or other. And so the purpose of this project is just to minimize those disruptions, so that way you can either stay in the comfort of your home, or you can continue to play your video games or continue to get your work done if that's what you're doing at the time. So how it works, as you can see here, you have a doorbell button initially, and so as soon as that doorbell is pressed, it'll go to the doorbell ringer, which every house has, and so it'll ring the doorbell, and so you'll be distracted anyways. And it will go to your Raspberry Pi, which is the software device that we are using to control everything here. And then that will tell the camera to take a picture, which will be posted on the front door, so that way you can see the picture of who rang the doorbell initially. And then you'll also go to a texting API, which I will be using Mime, in order to send you a text. And that way it'll send you a text with the picture of the person. That way you can see whether or not you want to answer the door, or whether you just want to stay at your desk or at your computer, or reading your book, whatever you happen to be doing at the time. So that's the process of how this works. And so for the hardware for this project, I compared two main operating devices, the Raspberry Pi and the Arduino. Both are very easy to use. They were intended to be helpful teaching tools for people that were new to programming and software embedded systems. And so the three main attributes I looked at when comparing these three was the physical size of them, whether or not they had internet capabilities, and also the operating system involved in the project. And so for the physical size, both of them were roughly equivalent in size, and also when looking at the project as a whole, you will have this board probably stored away in the ceiling, so you will not have limited space up there. You'll have pretty open areas, and so you don't have to worry about the size too much on those. But anyways, they are pretty equivalent. For the internet, the Raspberry Pi has a direct Ethernet connection, and so you can plug that right into your router, whereas the Arduino has to go through the computer in order to get internet, and in order to talk with the outside world. So you'll have to have another computer up there with the Arduino, whereas the Raspberry Pi, you can just have it up there alone without any other assistance, and you can communicate to it via the internet. And then the operating system. The Arduino doesn't really have an operating system, so it relies on the operating system of the computer, whereas the Raspberry Pi, it operates on Linux. And so a lot of this class we have been working with Linux, and so I feel very familiar with that, or I felt very familiar with that when I was going through the project, and so I decided to go with the Raspberry Pi instead. As you can see here in the picture, we have a ribbon cable talking to the outside world, and so that'll be getting your input from the doorbell, your output to the Raspberry Pi itself, and then we have the camera down here with a white ribbon cable, and so that's just the camera itself. It'll be transferring the image to the Raspberry Pi from that, and then we have our power source right here as well. And so everything is conducted on the Raspberry Pi, with just the camera being outside to take the picture of the individual ringing your doorbell. And so for the software, I will describe what the purpose of the software is. So when the software gets the signal from the doorbell that it has been rung, it will send the input or the output from that signal to the camera to tell it to take the picture. It will also send that output to the ringer in order to let it know to ring. And then it's supposed to send an image that the camera took via text to an individual's phone. In order to do that, the functionality used is an API. And so we are using MIME, Multi-Purpose Internet Mail Extensions. MIME is typically used for email purposes, but in this case, it is able to send a text to your phone via your email address. And so as long as you have a valid working email address, you're able to send text messages to multiple different phones, or you're able to send emails as well if you want to different email addresses. And then MIME is also able to have text or images or non-text attachments, voice, pictures, videos, whatever you want. So MIME is a very useful tool for that. And then also you're able to send multiple of those. A lot of these APIs, texting APIs, you're only able to send text, or you're only able to send images. So MIME was a really useful tool for that. We were able to send both texting, just to inform you that the doorbell rang, and then also the image that you wanted to send of the person at the door, so you can determine whether or not you actually want to go out there and talk to them, or whether you want to stay in your home. For future improvements for this project, the camera is one large thing, and so when looking at the camera, you have to take into consideration where you're trying to send it. To a computer, you can get nowadays a ton of pixels in a very small space, and so for if you're trying to send an email, you might want a higher quality camera than I am using. I'm currently using a 5 megapixel camera because I intend to send it to your phone, and so phones have about just less than 1 megapixel ability for the iPhone 5. As you go up to iPhone 6 and iPhone 6s, it increases the quality, and so I went with a camera that's able to do 5 megapixels, and so that way you can, and as the generations keep increasing in the quality, image quality, you're able to keep up with it with this 5 megapixel camera, because it's able to have such a high quality of picture. And so that's why the camera I chose. But as the generations keep progressing, you're going to need a camera with a better image quality if you want the optimal results from it. And so one future improvement is to get a better camera in order to send better pictures to your Raspberry Pi and via your to your phone via text. And then also an API. And so if you get a specific texting API rather than MIME, which is used to send email, it's very useful and valuable if you want to send email, and also, like I said, if you want to send multiple portions such as text or non-text attachments like we are doing here. So we're sending multiple ones, and so MIME allows that. But if you're just purely focused on sending texting one, you can probably get a texting API, which is a little more conducive to sending text to AT&T and Verizon. And actually all the carriers out there. For the one I am currently using, I'm just using Verizon phones. So I did not experiment too much with T9 or the different carriers out there. But if you get a specific API texting instrument, then that would probably improve the quality as well. So in conclusion, what I went over today, I went over the purpose of the project, the description of what it's supposed to do, and why I decided to pursue this project this semester, the hardware involved in the project, the software involved in the project, and then future improvements that can be made on the project as well. And that is the end of my presentation. Thank you.